Hello, and thank you for joining us. This is an overview and training of the Digital Input-Output Module, also dubbed the DIOM. It's for the Solartron Digital Measurement Network. Just to give you a quick overview, the DIOM is used when you are running Orbit through a computer and wish to use the DIOM to signal a PLC or outside sensors, perhaps for a light tower or an alarm, or a signal to the PLC to continue along a piece of automation. So here's a sample application. Let's say you're operating Orbit GCS software and you are taking some measurements with our 3mm digital probes. And you want to signal to a light tower as to whether a part is good or not good. You could use the DIOM for this purpose. Now here's a more complex application that can actually use our wireless technology. So let's say you have a robot that is using our mini probes to measure whether or not a bore is good. So a robot takes the measurement application and then it sends the measurement to our Orbit stack via Bluetooth to our wireless connection module. The data is sent to the PC via the USB interface module. The software then determines whether or not the part is good. Then it can signal the robot whether to scrap the part or perhaps put it back on the automation line and further the assembly. Now, Solartron is currently on its second generation of the Digital Input-Output Module. We will now call it the DIOM2. This module has 6 inputs, 4 outputs, and is easily configurable. For example, for outputs, you can select between NPN, PNP, or logic. There is no need to purchase separate modules, unlike other manufacturers out there. This is the pinout for the DIOM2. It does come with a 15-pin DIN plug. Pins 3 through 8 are for inputs, pins 9 through 12 are for outputs, and then pin 15 is plus 5-volt output, which I will explain in more detail in a second. Now for inputs, you have 3 types, which I thought we might just review. First, you have the simplest one, a single contact input. This is basically an on-off switch where a PLC or an outside sensor can flip on or off, and when turned on, it sends a signal to the DIOM. Then you have what's called a switched voltage input. And this is where the PLC or the sensor switches from a low voltage to a high voltage, activating the input. This is referred to as input high and input low. Those can also be reversed if you prefer. Then you have logic inputs. For logic inputs, the PLC either sends 5-volt signal or a 0-volt signal. 5-volt signal typically means on, and a 0-volt signal means off. This is set as active high, or called active high. You can also invert this, or that logic input. You can have that 0-volt signal mean on, and have the 5-volt signal mean off. For this, you set input to active low. So by default, input pins in the DIOM2 are configured to active low. Now the DIOM2 also has a feature called Debounce. Basically, in the field, sometimes external switches can sometimes come across bounce due to vibration, can cause incorrect readings on the output signal. If this is potentially a problem, the DIOM2 has built in what's called a debounce function. It filters out those fluctuations by taking readings over time. So this you can set from 0 by default, 5 milliseconds, 10, 25, or 50 milliseconds. So if you have a longer period of time, can actually filter out any type of fluctuations like what you see in the diagram there. Now there's some output basics as well. We have 3 basic types, NPN, PNP, and logic. NPN stands for negative, positive, negative. It's also referred to as pull down. The DIOM2 basically acts as a switch of negative current, like the circuit diagram that you see there. The DIOM2 comes as NPN by default. Then there's also what's called PNP, and this is used in different parts of the world. It stands for positive, negative, positive. It's also referred to as pull up. The DIOM2 here acts as a switch of positive current. So this is the basic pinouts with the DIOM2 if you want to do NPN or PNP. For this, you can also refer to the manual. Now we have another output basic, and that is logic. Again, 0 or 5 volts. Now, an additional feature that we have here is that if you need a power supply, you can actually draw that from the Orbit network. Both Orbit modules and Orbit probes run on about 5 volts of power. So you can actually tie the power supply in through pin 15. Now for programming basics for the DIOM2, if you are running third-party software and wish to run the DIOM2, you can refer to the programming commands on page 91 through 98 of the Orbit Software Programming Manual. Now, if you wish to set up the DIOM2 using the Orbit software drivers, there's actually a pretty simple way to do it. You simply open the Orbit 3 suite, go to Orbit Library Test, make sure you have your DIOM connected to an interface module, such as a USB interface module. Click Connect. Then once it pulls up, go to Network, click Ping, highlight the DIOM2, click the Module tab, and if you'll see on the right-hand side here, all the different settings for the DIOM2. Pin input status, which you can click Read. Pin output state, you can click Active or Inactive, and then Set. Here's your input pins debounce, then your I/O configuration for active state. Then here is your output mode, NPN, PNP, or TTL. TTL is also basically the logic input function. And then you can click Set. So here's a basic demonstration package for the DIOM2. So here you have an Orbit stack with the USB interface, along with the DIOM2 connected to this utility box with both inputs and outputs. And here you have a basic Solartron probe. So here we are on the main gauging screen for Orbit GCS. Right now we already have one digital probe set up, along with warning limits and tolerances. So as you can see here, we have a warning limit set up for plus minus 0.25, and then a tolerance limit of plus minus 0.5 millimeters. So first thing, of course, you must do is set up the DIOM2 on the hardware section of the Orbit GCS software. You want to, of course, make sure that your DIOM is on the Orbit stack, and click Find All Modules. So here's the DIOM here, and then you can double click it. Then let's just change the name right away. By default, of course, it's a serial number, but we're just going to call it DIOM2. And if you'll see for the module settings, that actually changes the addresses for all the input pins and output pins. You see all the settings here. So of course you have the input and output configurations. You have state testing here. Then you have I/O polarity. Right now by default they're set to low. For this example we're going to set them all to high. Then if you'll see here, you have input debounce. Right now it's set at 0, and then output modes, NPN, PNP, and TTL, which again can also be logic. So now once we have this all set, go to Close. So now it's named DIOM2 here. Now the next thing you want to do is actually you want to go to Dimension and start setting up logics. So let's just say we want to set up alarms for a warning limit as well as alarms for the tolerance limit, if the part is outside of the warning limit or outside of the tolerance limit. So here we go to Dimensions. And then instead of clicking Add Dimension, we're going to click Add Logic. So this we're going to put EP1 warnings and tolerance. Okay, so for Logic 1, let's set up the warning limits. We're just going to rename it warning limits. And then how this is set up is first you want to choose your output action. Right now it says display only. And this is where if you're just not wanting to use any type of the DIOM pins, you just want to have like perhaps an extra light on your screen. For this we're actually going to choose, you have the several options here. We're going to do set pass or fail. If you look on your right hand side here, it says true and false. True means that the event is actually occurring. So in this case, if your probe is measuring within or outside of the warning limits you have set, then that would be true. And then false would be that it's within the warning limits. For this, let's just change the colors. So for true, let's just change it to orange, since that's the color being used for warning. And then for false, showing that's within the warning limits. Let's just make that green. Now, of course, you can swap these if you want. If you wanted to have the opposite effect, then you need to assign a pin to it. So we'll just assign this first one, DIOM 2.0. Then the next thing is formula. What formula is, if I click set formula, you'll see you have a few options. K, not K, K and L, or K or L. Now, the letters basically signify the event. So if your probe is outside of the warming limits, that is the event, which we could dub here K. So let's go for K or L, because sometimes what a customer might want to do is have like 2 events occur before an alarm is set off, like perhaps 2 tolerances, for example, need to be out of line before an alarm is set off. So we're just going to do K or L, and I'll show you why in a second. Click select, and then you need to set your parameters. So I'll click set parameters, and if you go to dimension logic, you will see that there's a bunch of logics here. Warn above max and warn limit below min. Since we want this alarm to go off if it's above or below the warning limit, I'm just going to go warn above max and add. And then for L, I'm going to do warn limit below min. Click add and go back. Now, anytime you set any of these, of course, you click save. So now once we have this all set, let's go to gauge. So now you see you've got an extra alarm here. Now I'm just going to press the probe and see if it goes into the warning limits. And if you'll see, it turns yellow here. Then if you look on the box, that also activates the light for pin 1 on the demonstration utility box. So now let's set the same thing up for if you are outside the tolerance limit. Go back to menu, go back to dimensions, DP1 warnings and tolerances, and let's add another logic. Go here, set pass or fail, and we'll just have this be DIOM 2.1. Now for this, we're going to go a little bit different. We're just going to set formula to K. Click select here, and of course you can also set it the opposite. You can have it be not K, and then just have the alarm go off when it's not K. Click select, go to set parameters, dimension logic. Now if you'll see here, there's also an option, fail limit outside of boundaries. So this will turn on if it's above the tolerance or below the tolerance. So really between setting, you could set K and L and do fail limit above max, fail limit below min, or you could just do fail limit above outside boundaries, which will activate whether it's above or below the tolerances that you've set. Click back, and same thing here. Let's go to true and set this to red. So that means we're setting it to red because if it's outside of the tolerance, of course, we'll want to have a light on your screen flash red. And for false, again, we'll go with green. Click save. So now let's go to gauge. So now you have 2 lights. So here, now you're on orange. If we go a little bit further, and now that will flash red. Then if you look on the DIOM2 utility box, you'll see that 2 lights have now flashed. Basically output 1 and output 2. So now let's set up zeroing a probe as well as perhaps triggering a sample using the I/O switches on the DIOM2 utility box. So for this, we want to go back to menu, go back to dimensions, and now we're going to add another logic. And for this, we're going to just call it 0 trigger. So for logic 1, 0, for this, action. You'll see you have the 0 option. For this, the output DIOM pin is none, and then for set formula, you're just going to keep that at K. Now let's go to set parameters. Now here's a list of the DIOM inputs. For 0, let's just pick the first pin here, DIOM 2.4, click Add, then go back. For this, we'll just have the green light on for true, and then red light for false. Click Save. Now let's go to gauge. Now if you'll see, you have the 0 button up there on the screen. Now on the utility box, I'm just going to flip the switch. And if you'll see, now the probe is zeroed its reading. Then the next step, go back to dimensions, go back to 0 and trigger. Now let's add the logic to trigger the reading. Display only, trigger sample. Again, you don't want the output pins, you want to have an input pin. Again, formula is still set to K. Set parameters. DIOM inputs, we'll make this DIOM 2.5. Click Save. So now you have 2 logic elements up here. So now we're back at the main screen. First, of course, we want to start logging readings. I'm going to click Start. And now I'm just going to trigger reading, just like the video you see on the right-hand side there. And if you'll see, the logging light is also flashing on the lower right-hand side. Now I'll just click Stop Log, Menu, Part. Let's go to View Logs. Then here's the latest log here for the measurements that were taken. The probe wasn't moved very much, so right now the results are at 0. So this concludes our presentation for the DIOM2. Again, there are many more capabilities. You can refer to the manual for any types of settings. If you do have further questions, please contact your local Solartron representative. Thank you and have a good day.